Hi everyone. Are you able to hear me clearly and see the screen clearly? All right. All right. So yesterday, towards the end, we talked about how to do the stream processing. I hope everybody has tried it. No? No? All right. Hi Hank. Hi Leeladhar. Hi Rebecca. Hi Venkat. Hi Dabral. Hi Bharni. Hi Michelle. Hi Christine. Hi Shashi. So were you able to try the stream processing that we discussed yesterday? Okay, okay. But make sure whenever you have time, you must give it a try because lots of steps might look very simple to you when I'm doing those. And chances are that you will get stuck when you do those steps by yourselves. So feel free to watch the video and go through the slides. We have updated the slides now. Okay. And along with that, in case you get stuck, feel free to reach out to us. Okay. All right. Because that's very important. So yesterday in the session, what we did was, okay, let me save this. All right. Let me save the notes and if possible, give you a copy of this. Okay. Okay, so I think this should do. Just a second, I'll share it with you. Okay, so this is the notes for now, and later on, the same notes will be updated in the session. All right, great. Let's move on. As part of this session, today we are going to basically talk about the peripheral component around RDD, and then we'll talk about the rest of it. All right. Okay, so one of the common question is that we did word count, right? Word count per second on a continuous stream of data. That's what we did yesterday. Okay. Question that arises frequently is that what practical use case it is for? Okay. What kind of practical use case we are talking about? And how do we generally present this data in a very, very user-friendly way? Okay. So let me try to answer two questions. First, second one is related to presentation, and first one is related to the real use case of streaming. Okay. All right. So all of you, what is the single most um, interface or a dashboard that you use every day? What is that graph chart or what is that interface that you use every day where your where it is quite important to you to see the live data as in data without a lag, data without the lag, or the information without the lag. Okay, Shashi says trading and stocks. More than that, something that impacts your life. Okay, I again put the keyword dashboard. Does it ring a bell? Yes, yes. The dashboard, car dashboard. Okay, so when people say dashboard, somehow we forgot the reason why we call it that dashboard. Dashboard comes from car dashboard. Okay, on car dashboard, we would like to see the real-time data continuously as we are driving the car. We do not there is no point of seeing the data which is older, right? Does it make sense? So the word dashboard comes from the car dashboard, and that dashboard has to have real-time data. Imagine that your car is not showing the level of gas or the petrol correctly. It's showing the data around 2 hours old. So the chances are that you will run out of gas and you will not refuel it. So so that's why even more critical than that is your, let's say, driving speed, or let's say other signals that you get out of the car. Okay, therefore anywhere where you need a real time updation of the data, you generally use Spark streaming or other streaming solutions. And the whole dynamics is very different. Whole dynamics is different. I'll explain to you why. Okay. So usually the way people prepare charts is, so usually the way people prepare real time. I'm telling you the real time definition of most of the companies. Okay, I've seen many services company, and when I talk about real time, you know what do I get? They tell me that okay, this is a real time graph. It will get updated every 5 minutes or every 10 seconds. Okay, every 10 seconds. That's not, and every 10 seconds it's going to refresh the whole UI. Okay, which is a pretty bad experience. So usually people give me, when I ask them for dashboard, it's a stale data. Okay, if you have to build extremely sensitive, extremely live or real-time data dashboard, then you would require streaming. Now question arises that fine, we did the word count and we executed print, but how does that translate to the presentation? How does that translate to the presentation? Okay, how can we show it in a user-friendly way, right? So in those cases, generally we use socket.io along with the charts like D3JS. Okay, so socket.io combined with D3JS gives you real-time database, real-time data set or dashboard coupled with Node.js. So this is the kind of presentation layer. No, Node.js is a web server running continuously, to which your your streaming will keep on giving data, and it will keep on passing that data via socket IO to D3JS. Okay, so that's how we do the presentation. Did it make sense to you? All right. So whenever you have to prepare real-time updates, or you want to take a real-time decision, okay, in those cases, you would generally require a streaming use case. Yes, Jayaprakash, cricket live score comes real use case of streaming. Yes. Okay. So just that there is not much of a processing in this score unless you are providing something extra other than the real score. And stock also, stock and trading, as Sashi has told earlier, yes. So those are also kind of real use cases. All right. Hank's question is, what is D3JS? It's called data-driven JS. Okay, data-driven JS, and so you can see that. Okay, these are beautiful graph. So you must take a look at this new generation library for generating the graphs. Okay, all right, good. So that was about streaming. Now there are quite a few use cases which come into real application. So so the one which we had discussed was only reading the data from a TCP socket stream. What if we have to do it? Okay, let me just correct what I shared with everyone. Okay, what if you have to read from other sources? Now, in case of Spark streaming, the only thing we have to change is the starting point. Okay, the only thing we have to change is the starting point. So yesterday we basically took you through this exercise. On one end, we basically listened to it. On other end, we produced data. Okay. On one end, we were seeing this statistics. On other end, we were producing data. Okay. This was yesterday, and I wanted to show you that piece of code. Yes. So here you can see, here we are creating the connectivity. Right? The first time when we are creating the RDD, we are talking to a particular machine and trying to read the data over a network connection. Okay, over a network connection. All right. So we are basically connecting to a port. Sure, Deepak, I'll have it checked. Okay. All right. So here, this is the point where we are configuring the input source. Now, as you would guess by now, is when we are connecting to something else, okay, something else as in Kafka, Flume, HDFS, ZeroMQ, or Twitter, when we are connecting to any of those, only this particular line will have to be changed. Okay, only this particular line will have to be changed. Rest of the logic will remain as such, provided the data input format is same. All right. So moving on. All right. So What other sources could there be? First one was TCP connection. This one we have done. Okay, this one we have already finished using reading it from the TCP connection. We could also read the input from file streams. Okay, file stream could be HDFS or local file systems and so on, or network file systems. It could be based on custom actors. Spark allows you to create custom actor. Okay, custom actor. The way we had custom Flume agent, similarly, Spark allows you to create custom actor. Okay, the next one was the queue. Okay, next one could be the queue of RDD itself. If there is already another processing going on, and rest are advanced. Okay, so there could be many more as input formats that Spark Streaming can consume. The question from Sashi is, where did we give the input data format? So by default, when we provide a network connection, it assumes it to be a text one. We can change that. All right, sure, we will tell you how to change that. Okay, so yeah. So here we said socket text stream. Do you see socket text stream, right? So if we, let's say, let me try to show you here. Okay, and this today we are going to use latest version of Spark. So we are going to use user Spark 2.0.1 bin/spark spark shell. So you can see this. Now, I have to go back to this part. Okay. All right. So here we were basically saying, well, lines equals SSE dot socket. Yeah. So you have socket text stream. Then you have raw socket stream where you will get bytes, and it will be up to you to read the data byte by byte. Or, okay, so you could simply say socket stream. In those cases, you will basically get the data in the form of a stream, which you can later on change. All right. So using these methods, you can basically select whether you want to go with solid socket text stream or text file stream or raw socket stream. Okay. So those are the methods. There is something called binary records stream. This also you can use. All right. Good. Good question, Sashi. Now moving ahead. All right. All right. Let's assume that for a moment, as Shashi was asking, that we want to read the data from a folder in HDFS. Okay. Let's say you remember our discussion earlier where Flume was basically creating files in a folder. As in when it receives new data, it will push that data to a new file. That's what Flume was doing. Okay. Now, let's say you have the same circumstance. Let's say you have the similar circumstance where Flume is pumping the data, and you have to read that data from HDFS continuously. Okay. In those cases, you could read the HDFS folder from using the method called text file stream. For reading data from any file system compatible with HDFS API, you could use this function. Spark streaming will monitor the data directory. Okay. In case, okay, let's try to understand what does this statement mean, that Spark streaming will monitor this folder. In case you modify a file, it would not pick that file. It will only pick the file which is newly created. Okay. So a better idea, instead of changing or appending to an existing file, a better idea would be to create a fresh file. Only then Spark streaming will pick it up. And every file is going to be a single record. Every file is going to be a single record inside the RDD. Okay. So although directory within the directory is not supported, right now, let's say this data directory which you're passing as argument has multiple directory inside it. It won't pick those files. All right. So that's another way. Just, like sometimes, okay. So let's say we have a file being updated locally. Okay. Let's say logs are being generated. How would you send that data to Spark? Okay. So the general idea would be to start a service on a particular port and let Spark read from it. All right. Now the next important aspect is how to read data from a queue called Kafka. So Christine's question is, if you are processing 10 files in a directory and the streaming stops and starts, does it reprocess all 10 files? Okay. Should you move a processed file to, okay, yes. Should you have a process to move out files out of directory once processed? That's correct. So every time if you manually start streaming, what it will do is it will start from the beginning. It won't remember the point from where you had exited. In these cases, the ideal way would be that as soon as you push the data or read the data, process the data, move it out of that folder to somewhere else. Okay. It's a very good question. It's a very good question. And I would, yeah. So this question has quite a few connotations here. All right. If you look at this question carefully, imagine the same thing happens with a queue. Okay. And remember to remind me about this question once I'm done with Kafka. Okay, because it's quite important that I talk about it. Okay, so how would that be handled if we are using Kafka? Okay, so earlier, before even during Flume discussion and during our discussion on Spark streaming, we talked about unbounded data sets, right? So unbounded data set, we have just taken one case whereby we were generating data using a TCP port, right? Now, in industry, that kind of approach is not really great. That kind of approach is not really great, right? Because the way in an industry, there would be there would be many people, okay, producing alerts, okay, and many people consuming alerts. So in this kind of scenario, doing the TCP port is not really a solution. Okay, so let me take a step back and try to explain where the queue is used. Okay, so a queue is essentially for publisher subscriber kind of model. Okay, so let's say there is a queue like this. Many people are writing to it and many people are reading from it. Okay, and so this can be used at variety of cases. As I had given you the example of e-commerce website, that as soon as you make a purchase, that the one order is added here. Okay, one order is added here, and these processes read that order and make their action. Okay, like for example, detect the fraud on the credit card purchase, send the email to the buyer saying that we have received your order. Similarly, inform the availability team to reduce the item by one. Okay, similarly, send to the delivery team and the packaging team to start shipping the item. Okay, we'll basically inform the shipping team that this item has been received. Please please package it and send it. Okay, so there are many things happening parallelly. There are many things happening parallelly. Okay, and all of these things depend on certain input. So in such a certain scenario, you cannot write everything as part of as piece in your code, that if the order is received, then do this. If order is received, then do something else, and so on. We cannot keep on changing our main code, which receives the order, for multiple reasons. One, if there's too much of code in order receiving part, the user response will be delayed, right? So earlier, when I used to send email from my system, what we did was, uh, as soon as a user has saved some data, we'll send the email, then give the response to the user. Now user will have to wait for that long. Second, the code which is being handled on the code which is being managed by the website team is getting complex. Okay, therefore it's better to have your own ownership of the code instead of modifying the website. So for those kind of separation of concerns, as well as separation of the code, and making it easier for the user, this kind of publisher subscriber model come into picture. These are publisher subscriber model. Okay, now Kafka is one such queue, which is basically for publish subscriber messaging, meaning there are publishers on one end, there are subscribers on another end who receive the alerts as soon as publisher has pushed the data. Okay, it is distributed, partitioned, replicated, commit log service, meaning Kafka runs on many machines. It is partitioned, meaning even if some machines go down, okay, it can tolerate that. Replicated means there are multiple copies of the data so that the readers can read from multiple machines. All right, so that's Kafka. When you want to set up your own real-time processing system, you need all of this. First, you need a zookeeper. Okay, again, zookeeper is needed for the coordination because Kafka has agents, and Kafka agents need to coordinate, and that coordination happen via zookeeper. Then you require Spark for stream processing, and all of above are installed by default if you are installing using Hortonworks data platform. Okay, Ambari by default installs all of these. And Kafka library, you need to download from Maven, and we have also made it available as part of Data Spark. Okay, all right. Now, the here we have made it simple again by putting the example here. Okay, I'm going to change it a bit. All right. So Abhinav has done this one. Okay. All right. So same repository. Okay. Or you could also say git pull if you have already cloned. You could simply say git pull, and you will get the latest version. Good. Okay. You could basically either go to this Spark EX folder and say cd if you already have this, so you could actually say this and then git pull. Okay, makes sense to you? All right. So if you already have it, then you do. Okay. Next is you go into that folder. Okay, and then compile it. All right. So I'm going to do it with you. I already have this folder, so I can say git pull will bring the latest data to me. It is already updated for me. Okay, Spark EX, the one which we have done, and then UD. Okay, I'm extremely sorry. I think I've been copy pasting only to Deepak. Okay, so all right, good. SPT package will compile it. That's it. All right. Now, before we start running it, let's understand what's inside it. Okay, before blindly just doing it. So it's under Spark EX. The first example which you did was Hello World, how to package certain thing, and second was the streaming. So in this streaming, you will see these. Okay, so here what we have is this is the main file. Okay, this is the only file actually. There is something called Spark streaming library. It is essentially a connector. It is like JDBC driver. Similar to that, it's Kafka driver, which gives us the library to connect to Kafka. Okay. Then here is our logic to connect to Kafka. So we have config folder. Okay. You generally do not need it, but since we are starting this, and right now we want to run our driver on the local host. That's why we are using this one. Okay. Otherwise, we could also have just used new Spark Conf, and that could have been straightforward. Next is we are saying every 10 seconds, okay, create a D stream on 10 seconds, all right, meaning the batch size is 10. Afterwards, here we are saying, okay, here we are saying lines equals to Kafka utils dot create stream, all right. All right. Then we are saying, I mean, ignore the last part because that's not really required. And then we are saying words equals to line dot flat map, and then we split here. Okay. So we are doing the word count again using the same ways. Okay. Using the same standard techniques, and then forming the pairs, and then doing the reduce by key. And the way all the values are going to be reduced is by summing the two variables. And then we are printing it. Second argument in this streaming context is the batch size. Do you want to read the continuous input data every second, or 10 seconds or 2 seconds? Whatever you want to specify, you can specify here. All right. So I hope everybody is clear about it. So this is our logic that would start our processing, right? But before that, we have to understand a few more things. Okay. One thing I missed explaining is in an organization, let's say there is a huge queue, right? Some people want to talk about orders, and some people want to talk about photos, right? And some people might want to talk about the customers. Therefore, since to separate to do to so that to make the Kafka queue truly generic, what they did was they defined something called topics. So there are different topics which people can discuss about, just like in a discussion forum, and people can listen to different topics. Okay. So these are topics. And these are topics, topic 1, topic 2, topic 3. And the way you can visualize it is, okay, the way you can visualize it is that it has got data packets, okay? Like for example, in yesterday's exercise, Y was coming from here, Y was coming from here, Y was there, and so on. Okay, so these Ys were coming from the producer, and from this side, we were reading from here, right? And converting it into the RDDs. We were basically converting it into RDDs where Y was made like an RDD. Okay, so this way we were creating batches out of this continuous data. All right, so there is something called topics. Now let me also take the same question which Christine has asked earlier. Question was, let's try to rephrase this question in the context of Kafka. What happens when connection to Kafka is broken? Will it start from the beginning? Okay, let's say there is particular agent trying to read the data. Will a new coming agent would receive all the topics which it has missed, or will it not get those? Okay, This is a very interesting person. Interesting point of view, because when you have something like a queue, it is expected that connections will break, as well as multiple agents will come. Along with that, there is high chances that you are not able to read because of some error in your program, and your program has exited last time. Maybe your memory has overflowed, or something else went wrong inside your logic, right? So there are many reasons of failures, okay? And all of these failures are very well managed by Kafka. There are two strategies generally, that in case so as soon as you read data from the queue, it should disappear from the queue, okay? So that's how Kafka works. So you pick, as soon as you read or pick up a packet from Kafka queue, okay, it disappears from Kafka queue. All right. And in case you fail to delete a particular packet, the packet will reappear after some time. So as soon as you read, it will disappear from the queue, and then once you are done processing, you can delete it. In case you forgot to delete it, after some time, that topic will that particular packet will be alive again. Okay, so this is to ensure the failures do not lose on packets. Okay, did I make sense to you? Should I describe? All right, so question from Hank is, can you provide simple example of commercial application for Kafka queue? There are actually many commercial applications. The whole organization actually runs on queues. Okay. And as I was telling you the e-commerce example, let me make a drawing. I think then it'll make more sense to you. Okay. So let's say from a producer, there is an item called, okay, purchase. User has purchased something. So you basically put all the information related to purchase: item ID, user ID, okay, and address, and so on. So you basically put all these things in a packet and put it in the into Kafka. And there would be similar items, okay? There will be similar items, okay, in the queue. All right, you're purchasing something, and on the other hand, there will be multiple readers. Okay. Now, a very good question from Shashi. If there are more than one subscriber, then what if it gets deleted after the subscriber one? So the general thumb rule is, you know, what is the general thumb rule? That when one subscriber reads a particular item, it disappears from everybody else. Okay? If one subscriber reads a particular item, it disappears for everyone. Now, how do you ensure that everybody else also gets it? Now, there could be multiple scenarios. One, these are the threads of same process. Okay, these are the threads for same process, or they could be some other process as well. This is process one. Okay, this is process one, and this is process two. Okay, now in these kind of scenarios, what happens is as soon as you are reading a particular packet, it would disappear from the queue. Okay, so that so that if one thread is processing a particular packet, the other thread does not get it. Okay, otherwise two threads will start processing one one particular packet. Okay, one particular purchase order will be processed by multiple threads parallelly if it doesn't disappear quickly. Okay, therefore, now the thread problem is very well solved by making it disappear instantaneously. What happens in case there are more than one kind of readers? Reader 1 wants to inform about something, reader 2 wants to do something else. So in these cases, what people do is they create different topics, and as soon as this person has finished processing it, it will put it back. It will put this particular order back into the queue, into a different topic. Okay, this is topic 1, there could be topic 2. So once they finish processing it, they could do it parallelly. The other idea is that other way is that you mark a particular packet read by a particular process so that the other process can read parallelly. Okay, that's also very much possible. So Kafka provides both the ways. One, where you read it, and as soon as you read it, it disappears. Other is that it disappears only for a particular process ID, not for all. Okay, do I make sense, Sashi? All right. So there are two use cases actually. All right, moving ahead. Now, once we have done creating our code, which basically does the processing, let's try to set up the environment. Okay, one, you could log into your account, not this one. Okay, here we are going to use our own account. And second is set up this path. Okay, why? Because we want to interact with Kafka now. Okay, let's first set up the Kafka because we have to produce some data as well. Okay, so first we are setting up Kafka, and then we are saying here Kafka topic, create a topic, okay, called test. Let's call it August 27. Okay, that's our topic on which we want to talk. Okay, so first let's create this topic. Okay, and in case you want to keep your topic different, okay, it'll be a good idea to just have different topics, because if you try to produce, mm, it'll although it won't be a problem, but it would work a little differently. Okay, so you can see that here we are trying to see whether our topic has been created or not. There are so many topics that are there, you can see. Okay, these are so many topics created by the users. Okay, today's topic, the one which we are interested in, AUG 27. Okay, so this is our topic. Now, once we have created it, okay, let's try to produce some data. All right, let's try to produce some data. All right, in case if you are using some other cluster, first attempt would be to find all the brokers. So Kafka runs on top of brokers, the way we have master client relationship everywhere. Similarly, in case of Kafka, the actual work is done by the brokers. Okay, by the brokers. So we are trying to first find out what is the broker name. So how do you find out? Let's go to Zookeeper. Okay, let's go to Zookeeper. Then we say we have slash brokers, right? And slash brokers slash IDs. Okay, so there are so many brokers right now. There are 6 brokers. Okay, let's just pick one of the broker. So this broker, this particular broker, there are so many brokers here, which are created under znode slash broker slash IDs 0, 1, 2, 3, 4, 5, right? And if you try to get the 01, you will see the details here. This is the IP address, okay? 31, 13, 154, okay? You could also use broker number 1, okay? The IP address of that one is different. So this is a way you can, the way anybody, you know, any of these services find each other in the same way, we are also talking to Zookeeper and finding where are all the agents. So let's just pick the first one. And why are we doing this? So that we can talk on the topic and then we can launch our process. Okay. So here we are basically talking on a topic. Okay. And let me also log in parallelly. All right. What is my password? All right, so I will have to go to Spark EX folder. So on one terminal, the first terminal, we are producing the data. Sorry. Okay, this is what we were using. Okay, so here we go. So I've pasted the command again. Ignore the previous one. Okay, so I might have to change my password. All right. So on this one, we are going to run our streaming, and the first terminal we are going to use to produce some data. Okay. All right. Where is my slide? It is here. So if you want to test if it's working or not, we could actually use this. But we have to first set up the path. Okay. So we have everything in place. Okay, let's just see. And you see the flag called beginning? Okay. So looks like somebody is producing some data into this. Okay. It was, okay, this is test. Let's check our data. Okay, so let's just check. All right, so there is not much of a data here. Let me try to put some more data. Interesting. Maybe it will take a little more time. There's something wrong. Oh, we are producing on the topic, which is not required. Yeah, we had to produce on August 27, not on any random. Now you can see it's being consumed properly. Okay, so it's being produced properly, and you can see. All right. So from the beginning, it provides you an option called from the beginning, using which you can read it from the beginning. Okay. Now, all right, you can execute this command to produce a lot of data. Okay, to produce a lot of data that we'll do later on. Next is that we submit this one. But before that, I'd like to make some modification to my code. Okay. And what are those modifications? I would like to change the time here. Instead of 10 seconds, I would like to change it to, say, every 3 seconds. All right. Every 3 seconds. And then I'll say SBT package. And also I would like to change the topic. Okay, so topic is being picked up from the argument probably. Okay, so you can see. This one is something wrong with it. What does it mean? All right, let me just change it. Change the name to August 27. All right, so I've changed the name to this. Now let's call this. Okay. Although it's not reading from the argument, but still, we'll just change the name of the argument from test to August 27. Okay, it says that, okay, let me just package it first. All right, now let's try to see what was wrong in our command. Instead of this, we are going to use this particular command. Okay, so where is our code? Here we have written the command. All right, this is the command we are going to use. All right, let me just, okay, let me repeat what I have done so far. All right, let me repeat what I have done so far. First, I have set up a way to set up a topic on which we will talk on. The topic was August 27, and here we have created a producer, meaning whatever we type here on the screen, this is a dummy producer. It's a dummy producer on which whatever we are typing on the screen, it's going into the topic. Now, what we did was we basically compiled our package, okay, and we are saying Spark Submit. This is the jar, okay. This is the jar which Kafka guys have provided, and we have taken it from their repository. Okay, you could also take a look at this particular library, and instead of this, okay, so this is for Python. This one is for Scala. Same thing done for Scala. Here we are saying Spark Submit. Execute this particular command, a class, okay, because that was the name of our file. You see, it's the name of our file. Then not file actually, name of our class actually. Inside it, this is the one. Okay, so you can see it's a name of our class. All right. Then we're saying jars, pass this whole bundle of code or bundle of library alongside, along with it. And then we are saying, okay, we are saying execute this jar. Okay, execute this jar, run this particular class, and use this as library. And whatever is the output, send the verbose one std out, std error to dev null. This is called sending the error to the dev null so that it does not, blind you with the too much of text. It does not call, uh, it does not cause screen blindness. Okay, so all right, so here we go. It's actually starting to produce. So and right now there are nothing to be consumed. Let me just try to write here. Now you can see it's producing the results using Kafka. Good. Is it clear to everyone? All right. I'll just copy paste the command in case you missed it. Okay. So in our case, there was this queue and there was a topic, and the topic is called August 27. Okay. And on the screen, I am typing. Okay. So I'm going to say typing. That's going to, that's going to, that's basically a producer, Kafka console producer. .sh. This is library provided by Kafka themselves for producing data using a script. Okay. So this particular library is letting us put the data into this. Okay. Now, once you have this, then on the other side, so these we are basically typing y, y, y. That's what is flowing via the queue till the end. And on the other side, Spark streaming is okay. Spark streaming is reading this data and sending it to Spark. Okay, this is on Spark. There is RDD that's being created, right? There's the RDD that's being created. This is the RDD. Okay, and on top of RDD, your piece of code is being run. Okay, on top of RDD, your piece of code is being running. Your program is running on the top of RDD. Okay, so does it make sense to you? This question is, so Kafka producer agent must run in each node to produce messages? Not really. Not really. Whosoever wants to produce message can contact any of the agents or any of the any of the brokers and deliver the message. It doesn't matter. All right. Does it make sense? Or did I confuse you completely? So you are typing, it's going to Kafka console producer. Kafka console producer is taking your text, which you have typed, and putting it in the queue. And then on the other end of the queue, Spark streaming is consuming it on your behalf and creating a window. And for each window, it's creating an RDD, and then your program is consuming it. All right. So this question is, with Kafka, we can have both queue and a topic. So it's like this. Kafka is a queue which contains topics, and people always talk on topics, nothing outside. So for talking, for communicating producer and consumer, between producer and consumer, it is the topic. Okay. For producer, it's basically the topic is the queue. Yes, Kamal. Question from Dheer is it same concept as we have in JMS? Yes, it is same concept as with any queuing technologies. Okay, great. Is it clear to everyone? Do you want to see if it is able to produce really fast? So I'm going to pipe yes, and then see if it can consume it really fast. So you can see it's around 600,000 packets per second per 3 seconds. Okay, it was 3, right, for us? So this one is producing really fast. So you can see it was the difference between the consecutive is 3,000 milliseconds. Okay. So relation between queue and a topic is same as a discussion forum, and there are topics in discussion forum. People always talk on the topics, right? Instead of instead of mm, anything. All right. So basically, uh, Kafka is a queue which contains topic on which both producer and consumer talk. Okay, producer produces data on a particular topic, and consumer consumes data from a particular topic. Okay, without topic they can't communicate, because there could be many applications across the organization. Okay, therefore top idea of a topic is very important. Okay, without topic they can't communicate in Kafka. So somehow I'm not very impressed with this speed. It's only 197. Is anybody else also consuming parallelly? All right. I'm not very impressed with this performance because I generally get a million kind of performance. It's 500,000. Okay. All right. So Michelle is saying that she ran the first command and got a lot of messages about deleting. So that's why what I have done is I have put two here, two, then redirection dev null. Okay. And this command is quite useful because it will send all kind of verbose messages out, out of the screen. I think I should put that inside the code itself. Yes, that's correct, Hari. Other than it being run on this distributed systems, it is very much similar to the messaging queues that we have used so far. All right, great. So basically, this is what it is. All right. So we are able to consume data using the Kafka from the Kafka using Spark streaming. All right. So is the D stream that we talked about when Spark streaming library, when a streaming library of Spark, it reads data from a source. It creates something called D stream. D stream is a concept for that represents a temporary RDD. Okay. It provides all the functions that RDD provides, and it's basically kind of a wrapper over RDD. Okay. So you can see that all the functions, all the functionalities are provided as such. There is one functionality called update state by key is very new. Okay. Sometimes let's say you want to keep the statistics accumulating across the different D streams. Okay. Let's say what we are trying to do right now. Okay. Let's say we are trying to display only the statistics for last 3 seconds. Okay. We would like to also display the statistics of last 1 day parallelly. So for 1 day, we might have to keep updating that statistics. Okay, we might have to keep on updating inside the processing every time, and that's where update state by key comes into play. It lets you update a central state based on a key. All right, so that you could do the accumulation over multiple windows. All right, that's where the Spark, the update state by key comes into play. All right, sometimes you want to merge multiple RDDs into something called window stream. There you have the window operation kind of various kinds of window-based operations. You could create a window on top of a streaming context. All right, you can join two 2D streams, okay, as well as you could save the results from every D stream, as in here inside this. This lines is a D stream, okay. When you create a D stream using Kafka utils, so that's a D stream because it's not really RDD, but it's RDD only temporarily. So whatever logic you hand over to D stream, it will be executed on RDD every 3 seconds or 1 seconds. So on this, if you let's say you want to save it to HDFS, you can save it. All right, you can save it to HDFS in various formats, and it also provides a function so that you can execute a particular function over multiple RDDs. using for each. All right, so that was stream processing. Try to do whatever I did in the class by yourself. That will give you a very good confidence over these technologies. All right, any questions at this point? Okay, a question from Hank. Will you open the class for further function calls, APIs on Spark, SC, Kafka, Pig? Mm, actually, no. I mean, you mean to say that will there be another class in which I'll detail these things? I have not planned yet, Hank, but stay connected. I'll keep you in case there is a demand, in case other people are asking the same thing, then I might think of. Okay. All right. But in case you get stuck somewhere on certain point, please feel free to let us know. Okay. All right. Now moving ahead. All right. Any other questions at this point? No questions? All right. So the Spark team has done a really marvelous job when it comes to processing big data. Not only in terms of making, not only in terms of making RDD, and not in terms of making it really fast than the MapReduce, but also in terms of Spark SQL. What they have provided is the kind of abstracts they have come up with. On top of that abstract, they have provided very brilliant layers. Okay, so so for example, RDD was itself a very brilliant data set, or a way to represent data set. On top of it, they have created something called data frames. Okay, and on data frames, you can run either SQL, or you could run the other data frame APIs through R, or through any other programming language. Okay, so Spark SQL provides a programming abstraction called data frame, right? What's the difference between data frame and RDD? In RDD, we don't know the format of each record. Here, Spark SQL works on structured data. Therefore, inside RDD, inside every element, what are the columns? So Spark SQL assumes that the data which is there inside every element on an RDD is basically an array. All right, it's an array of data, the element itself. And that's how Spark SQL looks at the data in the tabular format. So it's a module for structured data processing. And what does it mean by structured? We know the structure of the data, and you can say that it's tabular kind of format. So Spark SQL is great when you have tabular kind of format. In table is made of rows and columns. Each row is an element inside RDD, and that's how it is represented internally. Okay, so you could mix SQL queries and Spark programs. Okay, so once you create, basically what they did, a very clever step, they realized that whether people are using R or SQL, the underlying data is same. Therefore, they created abstraction called data frame. Okay, so on data frame, you could actually mix and match various kinds of things. It provides you a uniform data access using Hive, Avro, Parakeet, ORC, JSON, JDBC. Okay, you can run unmodified Hive queries on existing data. And most important part to understand is that even if your Hive server is not running, Spark SQL can query Hive. How does it do that? Basically, it loads metadata from Hive, from basically Metastore, and from the Metastore, it infers where is the actual data and then uses that. Okay, so it basically uh, provides you a very strong way, very powerful way of handling tabular form of data or handling structured form of data. Okay, it also provides you a way to connect these. Create a server which can be connected via JDBC or ODBC. You could run Spark SQL thrift server, which will basically provide an interface to your data via JDBC. Okay, you can use existing BI tools to query big data. All right. So the entry point for all relational functionality in Spark is SQL context, class in subclass. Okay, so you can import this particular one. And in the console, you don't need to import anything. All right. It also provides you Hive context. By default, SQL context is Hive context, but you can change it. All right. The collection of data organized into name columns is what they call data frame, meaning every record, okay, every record, when you store data, the data frame contains rows and columns just like data tables, just that every column has got a name just like a table and so on. So data table and data frames are exactly same things. Okay, data frames are distributed in a Spark, and conceptually it is equivalent of table in relational database. A data frame in R or Python is quite useful. So pandas as well as the other other libraries have a similar concept called data frame. All right, it can be constructed from structured data files, tables in Hive, external tables, or existing RDDs, and so on. All right. A question from Dheer is, what is the difference between Spark SQL and Hive? Spark SQL is from Spark guys, Databricks guys, while Hive was created by Hadoop guys. Okay. While when you query Hive, underneath Hadoop's MapReduce is called. When you use Spark SQL, Hadoop's MapReduce is not required. So Spark SQL is only great for structured data. And for unstructured data, first you have to use your standard technique, whatever we have learned so far, like we did tuple processing and so on. And once you have created an RDD, you can convert that into a data frame, and then you can apply Spark SQL on top of it. Okay, do I make sense to you, Dheer? All right, let's take a look at So using SQL context, applications can create data frames. Okay, so we will try to read this data. Let's see if we can read it. And ouch, it's still running. All right, now let's try to start our. So this time we are going to use Spark 2. Okay, we are going to use Spark 2, and I think I got it. Okay, to run Spark 2, I'll have to use those variables which we talked yesterday, because otherwise it will not pick up the current installation. I think that's the reason. It did not do it on the cloud. It did it only locally. Okay, so we should do this. We should export these two variables, and that should be good. Okay, and then, all right. Not sorry, I'm extremely sorry. That's for 1.2. We will have to use the, okay, so exported, good. Now, never mind, I'll just type it. User Spark 2 bin Spark cell. So that's the latest version. That's the old 1.2.1 is oldest version. We are right now using the latest version. Okay. Okay, it's trying to connect. It is saying some error. Basically, it would be port related error, most likely. Yes, because somebody else might be using the same port. Okay, so it tried to bind it to 4043. It did not work. Now it would be trying 4044. Okay, so it is started with 4040, then 4041, then 4042, then 4043, and now 4044. And since my local machine is what? e.cloudxlab, so I can see the UI of this one here. I could say, instead of private IP, I'll convert it to public, because this is where my console is. You can see that this is the Spark interface. All right, so this is my latest version of Spark. All right, now let's go back here. Okay, so unlike this, let's try to see if, so here it says the Spark session is available like this, and SQL context, where is the SQL context? It has not created SQL context. Okay, so import spark.sql context. Let me see. there is a way. Okay, I think SQL should be there. Just a second, I'm trying to figure out. No, this is generally created already, Dheer. So I'm just wondering. I think they have removed that particular part. Anyway, let me try this. Okay, thank you. This works. All right. For time being, let's just stick with this. Okay. So they have done slight changes to the API in the latest version. So the difference is this. Thank you. Thank you, Dheer. All right. So let's try to load the data. Okay. So I just converted to lowercase because we have defined it as lowercase. All right. So what is it that we are trying to do? We basically trying to load data from HDFS at this location. Data spark people.json. Okay. And let's see what happens here. No, it's actually trying to read from Hive, which is wrong. Which is wrong. Well, this seems to work this time. Yeah, it did work. All right. So let me try to show you what is it that I'm trying to accomplish. Let's open the uh, hue and take a look at the data. Okay. All right. So here you can see inside the slash data folder. Let's go to slash data, and yes, inside the slash data, I have some more like Spark, and then inside Spark we have people.json. So it's a simple example of a JSON data set. Let's say you have some JSON records and you are trying to load that data into Spark. So Spark SQL will do it very easily. Okay, so it is loaded as a data frame. Let's take a look at it again. All we did was first created this. Okay, so first we launched our shell and then executed this. Okay, you can try this if you want to. So here we are saying SQL context dot read JSON from here. Okay, all right. So the only downside of this approach or this kind of model is it expects the JSON to be in certain format. It expects the JSON to be in certain format. Okay, so it expects that every row of a JSON, it's not really a valid JSON. I'll show you. This file is not really a valid JSON. Okay, let me show you this. So it says that multiple JSON root element. Okay, so it's not really a valid JSON. It's basically every record, every line is a valid JSON. Okay, every line is an object. First one containing uh, only one attribute. Second one containing two attributes. Okay, and third one also contains two elements. Okay, so whatever it encounters as key value, that key becomes the column, value becomes the value of that row, and so on. That's how it deals with JSON. Okay, is everybody with me on this? So if you have a kind of a huge JSON, you will have to first figure out how to break that file or how to translate that huge JSON such that every record is a JSON. This file is basically such that it's a plain text file where every record is a JSON. Okay, so we are able to load JSON data as SQL, and on top of this, we could do multiple things. Okay, so we can see the schema part. We could, print the schema. Right. So, so it's not a valid JSON, Christine. It's a valid JSON from the point of view of the expectations of Spark. Spark expects that there should be a text file where every line is a valid JSON. That's all it expects. Okay, so you might have to translate your data to this format, but interestingly, lots of humongous data is in this format. Okay, every record or every line is a valid JSON. For example, if you take a look at our Twitter data, the one which I gave for doing them for um, for the you remember our Twitter data, whereby we were trying to compute the analysis of sentiment. In the similar way, if you take a look at the other data set, most of them have similar characteristic. Let's say I go here, data. Let me go up. Let me go up here. So data sets, and we have, let's say, an Enron mail data. Okay, let's just pick up the emails of one person. Okay, let me just pick up the emails of all the, okay. Okay, not this one, not this one. There was another data sets. All right, I'll have to take a look at. There are quite a few, actually, I've seen quite a few data sets in which the data, let's say stock JSON, okay, stocks.json. Here, every record, every line of the file is a valid JSON, and that's all. The whole file is not a valid JSON. Next question is, what is the third argument in the struct field of df.schema? Okay, df.schema, where is that? When we say df.print schema, you mean this? Okay, all right, struct type df.schema. All right, it basically shows us the data type of this df is a struct, and these are the columns, is and name. That's all it showed you. A question from Sashi. What are parakeet tables and files? Okay, parakeet is a columnar format, okay, for storing data, storing complex data into a file. It's a serialization technique. It's a particular serialization format. All right. Okay. Now, on the DF is a data frame. DF is a data frame. So you will find many functions, such as group by and so on. Okay. So if I want to say select, okay, select, for example, and we can basically say pick up a particular column and then say order by age. Okay, it doesn't have the column because we have only picked up the second one. If I take this and I say show, so you can see now we have ordered the data based on the age. All right. So similarly, we could do a lot of magic here on the data frame. Say select select age, select name, comma age. I think this will work. And then I say show. Okay. And let's say I would like to order by. I would like to say change it like this. Now you can see. Sashi's question is DF also lazy evaluation? Yes, very good point, Sashi. It's also a big confusion mostly. So DF also tries to be lazy in evaluation. And that's exactly the contradiction is, because data frame, when we talk about R or other languages, there the data frame is not lazy evaluation, it is immediate. But in case of Spark, data frame is lazy evaluation. Good point. All right. So here we go. So we are able to do some kind of you know, querying. Okay. So it's a very simple querying way, and we could also put filter here. Filter. Okay. Age greater than 18. You can see that. So we can chain these things together and create a very sophisticated query. So a question from Hank is, are there any pros and cons? The pros of lazy evaluation is that it gives us a chance to optimize, as in combine multiple operations together. Okay. Cons are that you don't get the result immediately. So when it comes to big data, lazy evaluation is better than the immediate evaluation. In case of R, SQL, everywhere, the evaluation is immediate. But in the case of big data, everywhere the evaluation is lazy. All right. Well, another reason of being lazy is that it doesn't hold the data in the memory. It is basically a pointer to the data. DF is not really a data here. It's basically a pointer to the data, and same is the case with everything else, unless you call show. Okay. So that's one of the reasons. So in case of small data, yes, we can join in SQL. That's correct. All right. Going ahead, sometimes you would like to basically use proper SQL. Okay. All right. You would like to use proper SQL. In those cases, you could say SQL context dot SQL this. Okay. Also, for example, on DF, I think you can call SQL. Okay. Okay. So in that format, anyway. So we're just going to start from the beginning again. All right. So we can also say SQL queries like this. We will show you how to talk to Hive. Then it will make more sense. All right. So the concept of primary keys is not here. It leaves it to the metadata and so on. All right. There are two ways of converting existing RDD into data frame. What's the difference between RDD and data frame? Okay, let me draw it. Then it'll make more sense to you. All right. So let's go here. So here an RDD is like this. Okay. It has got the objects within like this. Okay. So for RDD, what's there inside the object does not matter. For data frame, it looks like this. It looks like um, I should draw it like a table. Okay, so data frame is more like a table, like here. Each individual parts, this is represented like, so it has got columns here like this. And similarly, every record inside data frame, it looks like this. They have got columns. All right. So this is RDD, this is RDD, and this is data frame. In data frame, every value or every element is in the form of a tuple or a row or a record. All right. So to of course convert this into this, what do you need? Convert this into this. A criteria on which to split the data. Second, the names of the columns. So we have to basically provide schema on top of RDD so that a data frame could be created. The name of the columns, the basis on which we are splitting the columns, that is the schema. So either we can infer the schema using reflection, or we can programmatically specify schema. All right. So like, for example, let's take the case of people.txt. Every line will be loaded as an element of RDD. Okay. And then to convert that people.txt, okay, we could basically create something called row. Okay, manually create the row, or or okay, so this is one way. This is called reflection way. Okay, or we could use other technique. We'll show you that. Okay, like here. All right. So this way is also okay. We are creating this. Here we basically splitting the elements by comma, then creating the row based on the map. And once we have created this, we are saying create data frame. We'll create the data frame. And then on this data frame, we can execute all kinds of functionalities. If we register it as a temporary table, then we can execute SQL query containing references to this table. All right. So first we loaded this data. This is in Python, so we can easily convert it into Scala. So first we loaded this text file, and when we load the text file, every element of the RDD is the line from this file. Then using map function, we are breaking every line into an array of words. Then from that array of words, we are creating row. Okay. And once we have created the row, then we are saying create data frame. We have data frame, and then we are saying register temporary table. Okay. If we register something as a temporary table, register temporary table, and we could also give a name of the table, my table here. Okay. So we have, okay, select star from my table. You see? You see that? So basically, once you register a data frame as a temporary table, you can access that using SQL query. Okay. So who all want to try it with me? Let me create it for you. Okay. So let me go back one more step so that everybody is comfortable. So who all did this data frame creation? Yes, using SQL, we can do the SQL statements, even joins, and joins from multiple servers. So you can basically create data frames from all across data set, whether it's in JSON, whether it's in HDFS, whether it's in network file system, whether the table is from the Hive. Okay, you can create the temporary table from any data frame, and then you can join those temporary tables. Okay. Pankaj's question is, can we cache the data frame? Yes, I think we should be able to cache the data frames. Yes, you can see that we have cached the data frame. Is the temporary table persisted? Meaning, if we exit the session, what would happen to the temporary table? It will not be available outside this session. All right. But data frame would be available. The original data from which data frame has been created would be available. Is it possible to keep tables? It is possible if you're using Hive, Or what you can do is you can just save that temporary table somewhere in the HDFS or somewhere else. All right. So these are the operations that are possible using SQL. All right. So you can create these. All right. This is another way of converting RDD, raw RDD into a data frame. All right. Let's take a break for 10 minutes. All right. Thank you, Christine. All right. Is everybody back? Should we start now? All right. So a question from Dheer is, uh, does every statement in Spark SQL create a new data frame? So, so I would put it this way, that every statement on on a particular data frame, okay, that creates that creates that creates okay, let me show you this. So df was our data frame. Okay, df was a data frame. That how did we create df? By loading JSON, right? By loading data formatted in the form of JSON. Okay, df we created that way, and when we said df.filter, it created another data frame, then another data frame here, and then another data frame. And once we said so, all of these operations got combined together and got executed on the cluster, and execution happened. All right, does it make sense, Deer? All right. All right. So, all right. There are times when you want to load the parakeet format. What is parakeet format? Parakeet format is an efficient format for storing columnar data. Okay, it's quite well known, and it's good for keeping it in the HDFS and other places. Okay, so parakeet is a good format, and it's basically a follow-up from the sequence file. Okay, so, or you can say there was something called thrift, and it is basically a follow-up of the thrift format. Okay, so we can also create data using create object or data frame from the parakeet. I'll show you. So here, let me go to Spark folder. Okay, so do you see users.parakeet? So it is not able to read that format because it's a binary format. So we can say here, we'll just say var df. Okay, let me clone it. All right, we could say var df SQL context dot read dot this. Also, very important part which I discovered in the new Spark shell, as instead of SQL context, you can actually use Spark. Okay, you could actually say Spark and dot read dot load. So they have just renamed the variable. It says the path does not exist, which is correct because our data is in this place. All right, so we have created new data frame. All right, so this is how we have been able to load our parakeet format. Similarly, we can save the data in the parakeet format. You can see that. So let's say you have the JSON data. Okay, let's say we had people.json. Where did it go? So JSON is people.json. Okay. Now let's say read.json. Okay. Now, if you see df.show, okay, you're able to read it. Now we can save this file. We can save the JSON format into, you could say, df.write.save. Okay. And let's say people.parakeet. Okay. The extension doesn't matter much in generally. Okay. And here we are saying format equals to parakeet. All right. So it says that it expects the path to be unit. This is correct, right? Okay. Let me try save option. Maybe they have changed it. And all right, let me take a look at it. So maybe they want me to format it. Okay. So it says that save should return. All right. So we'll have to take a look. This used to be correct. All right, let me take a look. And okay. Okay. So I'm generally referring to this particular documentation. You can also take a look at it. So I'm trying to save our data in the parakeet format. Okay. Do they have really? Interesting. So they have a format called parakeet, and there you can say my data. That's it. Okay, it already exists. That's not a problem. So we'll just say PQ. Wow, it has saved it. All right, so basically they have reorganized the API a bit. All right, so maybe we will have to update this. So if I go to my home directory, here, click on home, then if you open it, you can see this is the parakeet file it has created. It won't be able to load it. Yeah. Okay. So basically, you can write the, I mean, you can say df.write. Let me see, does it list? Here it says bucket by insert into mode. All right, there is, and you can also save it as a table. And you can save it as a text. Let me see, my file dot text. Okay, how does it look? Text data source supported only a single column, and you have two columns. Okay, so it wants us to, if we had only one column, it could have saved it. Okay, so yes, so that this is the one which could be used for saving the data frame. Okay, all right, so you can load the either using the Spark SQL or SQL context, or you can simply say spark.read JSON, and that should be good. Okay, so you can simply say this. All right, so if you say this, it'll be loading that one, and easily you can save it as parakeet. All right, so you can load data from variety of formats. Okay, variety of formats. So some of them you can take a look at here. Okay, so you can load the data from CSV. You can load the data from CSV. You can load the data from JDBC, and you can load the data from ORC format, parakeet format, and text file format. Okay, and so on. All right. So these are few ways of loading data. And of course, Hive, you can directly talk to Hive tables, okay, from here itself. So SQL, Spark SQL out of the box supports Hive. It supports Hive out of the box. Let's take a look at it. So we generally have, I'm hoping that this also has changed by now. Okay. Spark dot, I think it would be there. Okay. So let me take a look at, I think this also seems to get changed, but okay. All right. So basically here, there is one way to talk to, so let me take a step back and try to explain what is going on. So this, I think this will make a lot of sense to you. Okay. So here in this graphics, what I show is that at the heart of the whole thing is data frame at the center. So you can load data frame from JSON. You can create data frame from a table from Hive. You can load data frame from RDD, from a text file, parakeet file, and you can operate on data frame using SQL or filter or direct functions on the data frame. And on the data frame, you have usual functions like flat map, map, and other functions. Okay, and then you can save it to parakeet, you can save it to JSON, you can save it to Hive, you can save it to RDD. So data frame is kind of a central format for structured data. So you can load data from various formats into data frame and save the data frame into various formats. That's the core philosophy. Okay, that is the core philosophy. Okay, so this is one example of how you can read data from JDBC. Okay, but I'm expecting it to, you know, be different. Or should I do one thing? Should I just start with usual PySpark and everything should be okay? Also, the way Python tries to infer your Hive is by the way of Hive site.xml. Okay, so all you have to do is copy Hive-site to SparkConf, which we have already done. Therefore, it will be able to talk to Spark. All right, so it'll be able to talk to Hive, and let me try to see if they have changed this as well. So Spark SQL Hive, not this one. This is the one we are looking for. So interacting with Hive, the initial point is what I'm looking for. I think this should do good. All right. So okay. So I think I should explain this part and okay. All right. Right. I think I'll have to change few things right now that I'll explain now. Okay. So the things they have renamed SQL context to Spark now. Okay, as part of what did I do? Let me start from the beginning. Okay, so the main confusion that we are having since the beginning is how to basically get the SQL context, right? But interestingly, they have just renamed SQL context to Spark. Okay, and that means then we can simply say things like this: Spark.read JSON from this location, and data frame will be created. Okay, is that clear? So SQL context has been renamed to Spark. Okay, which means Spark.sql is a valid way of executing SQL. If you say enable Hive support on Spark.enable Hive support, there is a way to enable Hive support somewhere. Okay, so let me show you that part. So there is a way to enable Hive support that's based on enable Hive support there. Okay, that's on the server, on the session basically. By default, it should be available. Let me just check, okay? So spark.sql, select star from or show list. How do you list databases? Show tables, show tables. So there is no table. Let me try show databases. Okay, there is only one database. It's not connected to the right place. And it's not talking to Hive. All right, I think it's not connecting to the usual Hive. So let me just start with the older version. So, okay, I'm just going back to the older version. That will be easier for us right now. Okay, so this SQL context is the usual way of saying to talking to Hive. So I'm saying show databases. Okay, so you can see that it has listed all the databases, and it's only showing the first 20 rows. All right, so it basically has brought all the data list of databases, and I'm going to say use sg, use sg. Okay, now I'm going to say show me the tables, show tables. Okay, so you can see these are the tables which we had created while talking via Uzi. Now I could say easily here, select star, select star from widgets. Okay, so now this is a data frame. Now this is a data frame. Let's call it df2. Okay, this is a data frame called widgets. Let me call it widgets, which is being read from from the Hive. So widget has been fetched. Widget is a data frame, which is basically representing a table existing in Hive. Okay, so while the data frame, while this, okay, while the data frame which we were using so far, let's say this one, okay, this one is coming from, okay, this one is coming from, say, data Spark. Okay, so we have one data frame this way, and one we have widgets, right? Okay, so one we have widget and other we have df. So these both are data frames, If we register them as a temporary table, both of them, we can join them using SQL right away. Okay, we can join them using SQL right away, as well as we can join them using the the project or intersect functions. We could say intersect, and we can join with say widgets. Okay, using various kinds of syntax. So what I'm trying to show is I'm trying to show you this diagram. Okay, so data frame, we prepared one frame we prepared using SQL, other data frame which we prepared using JSON. Okay, and then we can interact with the other data frames using the methods provided on data frames, and then we can save the result in various ways. Is it clear to everybody this time? Okay, because they have been changing the API quite frequently, and that's the reason why lots of things have does not look good on the Spark 2. Okay, I think it's just the SQL context that need to be renamed to Spark. All right, that we will do it later. All right, so basically this idea of a data frame makes for a lot of ETL related problems. It solves a lot of ETL related problems. Okay, and it makes it possible. One, it makes it possible to join the data from different formats. It makes it possible to join the data from different sources. Okay, some lying in S3, some lying in somewhere else, and so on. So it's a quite useful idea, meaning having a central data structure to talk to all kind of sources and formats. Okay. Sashi's question is Spark doesn't seem to be backward compatible. Correct. Actually, the moment they changed the major version, as long as it was the minor version, they kept it backward compatible. The moment they moved the major version from 1 to 2, they basically broke the compatibility. Okay. So that's I think that's reasonable from their point of view as well, because it has changed a lot. All right. So other way of interacting with Hive using Spark is by the way of Beeline. Okay, by the way of Beeline, which is shipped with Spark. So you can see we are saying user Spark to Beeline. Okay, now we are saying connect to this particular one, and I'm going to supply my login password. Okay, now I have been connected. I'm connected to my Hive. Okay, let me show you this. Use SG, show tables, select star from widgets. Okay, so Beeline makes it possible to provide you a Hive kind of interface. Okay, it provides you Hive kind of interface. The only difference here is that when you do the computation will happen inside Spark, not MapReduce. Make sense to you? All right. Now, whatever operation we were trying to do, like filter, do this, do that, all of that is also possible using R. Okay, and Spark R is basically an R package that provides a lightweight front end to use Apache Spark on R. The way PySpark means Python console with a connection to Spark. Spark shell means Scala console, which has few objects from Spark. Okay. Similarly, Spark R is R package that provides lightweight front end to use Apache Spark on R. Therefore, when you install a Spark R, you have to install R first. Okay. So what it has done is the way uh, PySpark provides a entry called SC, Spark context. Okay. PySpark provides an additional variable called SC inside the console. In the same way, Spark R runs R and adds one more variable to it. Okay. So, okay, those who are not aware of R is a very good language. It basically is very sophisticated language for data churning. Okay, data scientists use R extensively along with Python packages, and R has got the largest library on the planet. R has got largest library on the planet, meaning it has got library for almost everything, starting with social science, psychology, biology, and finance, statistics, everything you will find a package in R. Okay, so and the problem with R is very sophisticated place. I mean, console whereby you can uh, inspect data, do hypothesis testing, do all kinds of statistical analysis. Along with that, R provides a lot of packages for machine learning. Okay. Now, the problem with R was that the data was loaded into the memory. Since the data was in the memory, what started happening is that you could not churn data beyond what could fit into the memory. Also, for complex algorithms, for complex algorithm, you would want to use many computers, not only one computer. That was not possible in R. But after the Spark R, a package provided by Spark guys, after this, it is possible to do a distributed computing on R. It's a very big it's a very big case because all the people who are data scientists and were using R will be using Spark R maybe few years down the line or few months down the line. Okay, because Spark R has been released around 6 months back. Okay. So a data frame in case of Spark R is a distributed collection of data organized into named columns. Every element of the RDD represents the row of the data frame. It's equivalent to a table in relational databases or a data frame in R, but with richer optimizations under the hood. And these optimizations are one, the lazy evaluation, second, executing logic near to the data, and so on. And as we saw during Spark SQL, it can be constructed from wide variety of arrays, a wide variety of sources such as JSON, parakeet, RC file, and Hive tables or normal databases. Okay, so data frame in Spark R could be loaded from variety of sources. All right. So here you can simply say, instead of this, you could simply say, okay. something like this. All right. So you could simply run R like this. All right. And then you can create the data frame like this. This is the default database. Okay. Instead of Spark SQL, I'm going to use Spark SQL. I think Spark will be the variable. Nice. Yes. Spark is the variable. All right. So this is Spark is the variable. So it has tried to load data. Don't worry about this error. Okay, so it has created the data frame representing some sample data. This is the volcanic eruptions data that comes with R by default. So when we say head df, it shows you the details about the volcanic eruptions. All right. So essentially, it has made it possible to run the computing in a scalable manner. All right. So you can load data from variety of sources. I'm not sure if it can load data from HDFS. We might have to change the format. This will have to be renamed to Spark because in its Spark 2, they have, okay, did it work? People.had, had people, not people.had. Yes, it did work. Okay, so this is, so it was able to actually read from HDFS. Now, this is a very good example if you look at it. Okay, this is a very good example. What a data scientist need is some data to process and then a library of algorithms and R, right? At most of the times. And this particular example, what we have done just now, shows that how to read data from HDFS, the usual location where we save the data, and then apply R on top of it, and that too in a scalable manner. Okay, so it's a big boon for anybody who is trying their hands on big data. Okay, any data scientist who is trying their hand on big data. All right, so do you want to try it, or you will try it at your own time? So all you have to do is set the environment variables, those variables which I had sent you earlier, and then try this. I'll show you the details of the this particular file. Okay, now on top of it, all the functions which are there in R to churn data, you can apply those functions on top of this particular data frame. Okay, for example, we have select, we have column selection, and so on. Okay, say you want to do this way of comparison in R, or you want to summarize what's going on inside. All right, so all of this is basically getting translated into RDD underneath and getting executed. Okay, so you can see that something of this sort, okay, whereby we would like to apply a lot of computation. Okay, we are saying that give us these many records, and we are saying group this data, group this particular data based on this, and then summarize the results. Okay, yes. Okay, all right, what does it mean? So let me first summarize it. Okay. I think for summarization, you need one more column for mentioning what. This question is Spark R is available in Spark version 2 onwards. It was actually available in 1.6 onwards. Okay, it was available only in 1.6 onwards. All right, so we could do all kinds of experimentation in R if you're comfortable. It was not available in 1.2 or 1.5. I'm not sure if it is available in 1.5. As per my knowledge, it was not available. Let me see. Spark, no, it wasn't available up to 1.5. It was available only after 1.6. All right. So basically, you can see that if you are comfortable with R, you can use the, okay. All right. So these are few queries. You could give it a try. And instead of this, you could use data/Spark. I've uploaded all of the data. And here, instead of SQL context, you could say Spark in the latest version. All right, so that should be good. Rest would remain same because as I was telling you that in the latest versions, they have renamed Spark context to Spark. All right, so that's pretty much with respect to Spark R. All right. Now, so did I take you through the demo of machine learning earlier? So all of you, the class might get extended by 15 minutes. Okay, so be with me. Okay, so did I give you a demo of Mario? Did I show you Mario? Okay, I'm going to take you through Mario before jumping into machine learning. That's something interesting. And okay, I'm going to show you Mario for now. All right. All right. All right. So how many of you have played this game called Mario? Wow, looks like everybody has played. Okay. So, and how many of you have won the princess or rescued the princess? Wow, Japrakash has. Wow, Shashi has. Deepak has. Wow, looks like my class is a rock star. So, okay, so at least 5 of you have won the princess. Now, how much time did it take you to win the princess? Learn and win. Yes? Multiple days or months? Okay. All right. All right. Good. So now, can you believe that a computer can learn by itself and play a better Mario than what we could play? All right. So this guy, what he did was something really interesting. What he did was he hooked a machine learning bot to the virtual machine of Mario. He loaded Mario, the NES, into a virtual machine player. Okay. Basically, he loaded this game into the computer. Right. His name, I missed his name. I'll tell you. I'll share the link. Okay. And I actually remember his name. And okay. So what he did was something very interesting. Although he did not invent an algorithm, algorithms was there. All he did was he hooked the he hooked the algorithm to the bot. Now what he did was to the algorithm, what he did was that the bot will keep on continuously pressing the buttons and observe whether it's getting a good score or not, and learn from its mistakes. Okay, so given the past history, which button should it press in order to win is something machine learning did. Okay, now let's take a look how brute force does it look like. Okay, Sabanand. Now, so what you see here is the starting of the game. Computer pressing keys randomly and observing whether the score is increasing or not. It dies of old age. Okay, Mario dies of old age. Now it automatically restarts the game and keeps on trying for a couple of days. Now it's looking little better. Okay, now it's looking little better. It's able to jump, it's able to move forward, and I don't know why it's facing backwards, but it doesn't matter. Now after a few more days, what you see here is Mario doesn't seem to have a problem jumping around. See that? It is stuck. Do you think it'll clear? Do you think it will get past this? It did. All right. Now what you see is just magical. It has no problem at all. It's playing like a pro. And few more weeks, it is more than an expert. It is more than an expert. What you about to see is something wonderful, something magical. Okay, something that you never did. What was that? What was that? You see? So even though Goomba was jumping on Mario, the bot has figured out that the moment when the Goomba is jumping, it starts moving downwards and exploited the bug. And now you will see Mario exploiting another bug. What was that? It figured out that it is possible to jump over the edge. Now, the another sign when the same algorithm was tried again and again, okay, on another game, it did not work so well. The only thing it realized was that pausing the game did not decrease the score. So it started pausing the game. Okay, do you remember the childhood where your cousins or siblings would spoil the chess game when they are not winning it, right? Or a carom board. So in the Tetris, when the program was not able to win, it paused the game. Now this is the sign of intelligence, right? So what you just saw was that the computer, who has no idea about king, queen, princess whatsoever. It has no idea about evil or good. It has no idea about the gravity or jumping or physical forces. All it was given was the buttons to press and score to monitor and see the screen. And it figured it out by itself how to win in that game. And it even went far ahead from our imagination in exploiting and finding bugs in the Mario game. So this is machine learning. This is what proves that no matter how well you would program Mario to win this game, you won't be able to program it this well because we couldn't find these kind of bugs ever. Okay, so similar thing happened in a competition between AlphaGo, an algorithm by Google, and the world champion of the Go player, where AlphaGo won, and the AlphaGo won by a huge margin, right? So against the world champion of Go. So there, what they did was instead of programming AlphaGo, they let AlphaGo play against itself again and again forever. And that's how AlphaGo had developed this ability of playing Go game really well. So this is machine learning. This is so there's a difference between usual computing. In usual computing, you write the algorithm, while in case of machine learning, you clean up the data and feed the data to the algorithm so that algorithm can learn from it and build the algorithm internally for solving certain problems. Okay, so this is machine learning. That's correct. So you never know. All right. Now imagine doing the same thing for life, gathering data and figuring out what exactly is the cause of cancer, for example. What could solve the poverty of the globe and how to stop Donald Trump. So those kind of problems could be easily solved with machine learning if provided we had enough data. All right. So yes. All right. So yes. So basically, what you saw just now is a program becoming so good at figuring out things by itself is is threatening to the humankind. All right. Was my screen paused all this while when I was showing you Mario? Okay, I think it got paused just now. All right, I think it was the game that paused it. All right. Okay. Good. So that was the introduction to machine learning, and probably that's the best way to understand it, because when you look at the algorithms, you will think that it is nothing but our usual mathematics. But you have to keep in mind that it's a branch of artificial intelligence for the design and development of algorithms, where computer evolve behavior based on empirical data. Now, after watching that game which we just saw, these three sentences will make sense to you. It's a branch of artificial intelligence for design and development of algorithms, because we did not write the algorithm to win Mario. Instead, we provided empirical data. We provided empirical data so that computer could evolve its behavior, could learn the game. There are three types: supervised, unsupervised, semi-supervised. You can take a look. So basically, in case of supervised learning, okay, In case of supervised learning, you have labeled data that this is good, this is bad. So let's separate the two things, and we train the computer to do that separation of good versus bad. While in case of unsupervised or semi-supervised, we say that here is the data. Can you create 20 categories out of it? Or here's my inbox. Can you just group my emails into 15 buckets? I'll figure out later on what basis you have done. So that's unsupervised. In semi-supervised, it is somewhere between the two. Okay, there are many applications of machine learning, and one of the applications which we have recently published is based on TensorFlow. So almost every aspect of computing is going to be impacted, is being impacted by machine learning. For example, understanding voice, understanding visuals, understanding uh, the graph of friends, and understanding the customer behavior, and so on. There are many more use cases of machine learning. If the data is small, the whiteboard is good enough. If data grows a little bigger, you can use R, MATLAB, Octave, etc. If data goes further bigger, you could use NumPy, SciPy. But if the data goes further bigger, then you would have to use tools like MLlib or Mahout. Okay, so MLlib consists of algorithms in different kinds. Classification, as in putting things into buckets like good, bad, or uh, or let's say we want to bucket something like ABC, we want to categorize things. That's classification. Regression is predicting a value based on the current values. Clustering is taking a group, taking the elements and grouping them into various buckets based on certain criterias. Okay, and collaborative filtering is recommendation. Okay, generating the recommendation. Dimensionality reduction is reducing number of dimensions, meaning, let's say, what does it mean by dimension? Let's say your salary depends on many factors. Okay, such as how many years you have worked in a company, how great are you with the technology, how great you are with the people, how great are you in that particular climate, and so on. So if you have to figure out what is it that my overall salary should be, then you will have to provide all these variables, right? So when you provide these variables, sometimes it happens that there are a lot of variables that are not really required. So we have to reduce that particular dimension. For example, it doesn't matter whether it was year 2015 or 2016 for which impacted your performance, right? So the year did not matter, for example. So, but maybe it impacted because age was different. So you have to. Sometimes it's important to reduce the number of dimensions so that your overall performance of figuring out the performance of algorithm of machine learning could improve. Okay, and MLlib provides a lot of primitives on top of RDD, which can be used, such as matrix and others, and it provides API for pipelining various kinds of learnings. There are two packages, MLlib and ML, which provide you the package for doing this. It provides you various kinds of data types such as vector, labeled point, because these are something which are used again and again, and matrices like distributed matrix and various kinds of distributed matrix. Okay, so MLlib provides you the basic statistics functions, and it provides you all kinds of classifications and regressions. All right, these are the various algorithms which have been ported from a smaller data to big data, because computing mean or computing average itself is a big challenge if the data is used. So are everything else that depends on basic summations. Okay, so collaborative filtering is one example that's commonly taken, and that's what we are going to talk. So it basically lets you prepare the recommendation. What does it mean by recommendation? Let's try to understand. So if you have a lot of, let's say when you go to Amazon site, or let's say you go to Netflix, they give you the suggestions for movie. That's called collaborative filtering, the recommendation system. So what do you need for that? You need to know about a person's info, like if you know about a person, whether it's a male, female, what's the age, where does it live, and so on. So if you know who are the people who are voting for these movies, and when you know the movie genre, you can basically figure out similar users and similar movies, and hence give the recommendation. All right. So this is a code that will take you through the uh, through the this is the code that will take you through the um, recommendation generation. All right. Japrikas's question is, Google Allo uses ML, it seems. The app is equipped with the smart reply feature earlier seen in the inbox, right? That's correct. It suggests automatic, yes, I have used it. So it uses AI to read text and reply pattern of the users, and then it comes up with relevant suggestions. Yes. So I've used it earlier. Okay. And it is pretty good, and we are trying to build a similar thing for our customers of No Big Data and CloudX Lab. Okay, let's see if we are able to finish that. And so yes, so some of these companies are using MLlib, although before MLlib they were using various kinds of other libraries. Say for example, they were using Mon Oct, and they were using few more. So at least I was using a library called Mon Oct. Okay, but I think most of the people are now starting to move to MLlib. But having said that, a lot of companies have smaller data that can be very well handled by a huge machine of 100 gigabyte RAM and so on. Therefore, lots of people end up using still R and say Python for machine learning. 90% of their work is done there in the Python and R. Okay. All right. So let's try to understand what is going on here. All right. So here, let's take a look at the data. Let's take a look at the data. We go to this particular folder called Data Spark MLlib. Oh, what happened? Okay. Here in this, you have ALS. Okay. So ALS is the particular algorithm. Okay. In this, we will try to compute the movie ratings. So we have movies. You can see we have movies, and we have ratings. These are ratings. This user rated this particular movie this much at this time. All right. And test your data. Okay. This is a data which we want to test. Okay. We will learn from we will learn from ratings data, okay, and we'll apply that learning on tester data. Okay, let's see. So first of all, we will load this data, okay, and then we will break this into ratings. So this code is in Spark, so I'm going to use PySpark for now, but you can translate it into Scala as well. I'm using PySpark for now. Okay, let's see. Here data equals to text file. So note that we have loaded test.data as a test file, okay, as a text file, not test file. Now we are splitting this data and only converting this rating by picking only the first three columns. First one was the user ID, second was movie ID, third was the rating. Okay, so we have converted that into rating. So most important part is we need this object called rating. Okay, also we need to import this particular library. Now, so these are the two parameters that are needed by the algorithm. So if you have more number of iterations, you might get a better results. All right, for time being, we are just using this much. Now we are saying that this particular algorithm that we have imported here, we are calling it ALS. So we are saying ALS dot train on this rating and this rank and this iteration. So actually we are training on test.data. We are training on test.data. So it is basically running it and learning from this data. Okay. Now, so this test.data, what you see here is all right, test data. This is the again we are loading the original data. Okay, so this is the model that we have prepared, meaning this is the learning that you have got out of training on top of this ratings. Okay, now we are going to apply this trained data on the same data set. Whatever we learned, okay, whatever data we learned from, we are going to again apply on the same one to see how well it's performing. Okay, here we are saying now whatever predictions we have got, okay, whatever prediction we have got, we are trying to join with that same original data so that we can prepare the delta. Okay, so basically we have ratings. A person liked a particular movie and then uh, this much, right? Now it is trying to predict on the same data set and trying to compare the results, okay, so that we can validate how well it's performing. Okay, and how do you do that? We are computing the distance, meaning delta, summation of delta and the square. Okay, and then once that's done, we are going to print how much is the error. So based on the same data we learned, and then we try to predict the movies for those users. You can see that we've only picked up first two columns, meaning user ID, movie ID, and removed the ratings. So for this test data, we're trying to figure out what kind of predictions do we get based on what we learned earlier, and then how far are these predictions from the original data. That's what we are trying to do. It will take time. It will take time. All right. So this is MLlib for computing the for computing the recommendations. All right. On the similar line, let's say you have lots of emails containing lots of text and you want to convert them into multiple buckets. In those cases, you can use the clustering algorithm. Okay, there are many clustering algorithms. One is k-means, Gaussian mixture, and so on. To figure out which one is suitable for you, you might have to understand the algorithm underneath. But mostly, if you have to categorize things into buckets, n buckets say, then k-means is good enough. Almost half of the industry uses k-means. All right, here is one example whereby we have tried to show you how to put data automatically into different buckets. We are only defining the distance method. We are only defining distance method. If you are interested in machine learning more, take a look at these algorithms. The good part why I'm talking about machine learning in an engineering class is that one of the best data scientists, for example, Jeff Dean, the guy who wrote the paper on Hadoop and who was working on these technology, he's essentially a basic engineer. He has no degree in statistics. He has no PhD in machine learning, nothing. Okay, so basically, machine learning as a discipline is something which will become a part of undergraduate, and it's actually quite easier to use. And I I did not realize that it was so easy to use because most of the algorithms are available as part of standard libraries. It's just a matter of modeling the problem. On what basis do you train? On what basis do you judge whether it's trained or not? So that kind of becomes very easy. And as of today, the main problem that would remain would be the ability of cleaning the data in order to feed the machine learning algorithm. Okay. Sabanan's question is there any course you recommend on deep learning? Actually, deep learning courses right now, I'm not very impressed so far with any of the courses. Okay, even the one which the only one close that coming closer to uh, by Udacity. Okay, Udacity on TensorFlow. All right. So these algorithms are very well available for you. Similarly, there is a library called GraphX. GraphX is for computation on graphs. It extends the Spark RDD such that the graph can be represented as an RDD, and it provides the fundamental operators on top of this graph, such as subgraph, join vertices, aggregate messages. Okay, it has got standard library, and the first algorithm probably every graph processing library does is PageRank. PageRank basically provides a way to rank various nodes in a big graph. So if my website is pointing to you, your website is pointing to somebody else, and so on. Out of these websites, which one is more important? That is PageRank. And it is designed around the fact that if more people link me, my value becomes higher. If more people whose rank is higher rank me, my rank is even further higher. Okay, so similarly, there's another algorithms that are required quite often called connected components. Okay, say for example, out of your friends who are connected amongst themselves, that's connected components. Then triangle counting. Okay, triangle counting, because on a larger surfaces, on huge large surfaces, you generally try to find out how many triangles are passing through each vertex, because surfaces are generally represented as combinations of triangles. Okay, So here is an example of how to prepare the page rank. It's pretty straightforward. You can try this one. So first you prepare the graph based on the data. Okay, you have followers data, who is following who. Okay, two column data. First column contains who is following, and second column who is being followed. Okay, once you load this data as a graph, then you can just set the page rank to all of the nodes, okay, as the 0.001, something like this. And then here, okay, you can split the fields by comma and all right, and so on. Okay, so basically you can see that a complex algorithm like PageRank becomes very easier using graphics. So graphics is another library built around Spark. So you can do graph processing, you can do machine learning, you can do data cleaning and data churning, and the basic machine learning using Spark R, Spark SQL, and using Spark streaming, you can process a lot of fast moving data. And before that, the RDD is a raw way of computing things. All right. So that's pretty much about the graph processing. It's still stuck somewhere. All right, never mind. I think the screen is frozen. All right, so that was pretty much about Spark. Okay, so if you try. Okay, so I'll take two more these questions and then I'll talk. All right, a question from Pankaj. Okay, what certification is good to go with and how to prepare for that? Okay, and do you have any sample of certificate questions? So interesting part about most of the certifications today is that all of these certifications are trying to see whether you are hands-on or not. Okay, they've removed most of the theoretical question, and for our student that has become far more easier because whole of our learning is hands-on. Okay, so I think uh, the Cloudera certificate is also quite popular and is being used. Same is case with Hortonworks. Out of Cloudera and Hortonworks, there's I can't differentiate much. Just that what I understand is mm, these certificates would not really matter a lot. Okay, don't have huge expectation because the organizations who are really serious about hiring somebody into big data, they generally have their own interview and interview and the tests. Okay, so therefore these certifications are only good for getting filtered through the resume scanning. All right, so yes, now let me go back a bit. So as a project, so project is fairly hands-on. Okay, and let me open the my courses tab. All right, let me go back here. All right, so in the last session, you will see the project one. You see the project? Okay, here is the project whereby the description is basically for processing the data set, this one. Okay, and you can try there. Okay, so you pick up these assignments from here. So this is the problem description, and here are the questions related to each problem. Okay, so it essentially is data from NASA access logs, and based on this data, this is the format of the data, and then there are 5 questions. Okay, so please prepare solve these 5 questions either using Spark SQL or using RDD or using basic core Spark, and that should be good enough. All right. So these are the real problems which people would like to know out of their data. All right. So that's pretty much about the assignments uh, as a project, and of course the Twitter data is also the project related to Twitter is also important. Okay. Any other question? A question from Dheer, how to prepare for CCP data engineering exam. So again, Cloudera also has changed their format. Just take a look at their problem. So whatever we have done as part of PIG, as part of other work. So as part of PIG, Hive. So what they did was they have basically converted everything the uh, uh, into the way we have given the assignment, like session 14, or the assignment in the session 4, the big one. You can try that. All right. Sashi's question is, what should be our next step to get more hands-on? One would be that you finish these 2 exercises, and once you're done with that, we most likely would have some more projects I mean, real life projects coming from the industry. So we will try to see if we can align you with the industry projects. Okay. So that's another further. Okay. So once you are done with these basics, then we can move on to the industry project. All right. And Jayaprakash is saying, how many days will we have access to CloudX left from today? I think it'll be one more month, I think. I'm not sure. I'll have to check. So it is supposed to be for 90 days. Pankaj's question is, somebody asked in one of the previous sessions to take us through a typical big data workflow as can be encountered in industry. Is that possible? So I would say that I'm actually finishing it up. Okay. So a couple of industry projects which I have recently finished. I would like to share that one with because I did that with one of our students, and I would like to share that with everybody. So that will get published maybe in couple of days. So I think after that you will get far more clarity. Okay, because right now I think it will be better that if you go stepwise. Okay, maybe by end of the week. All right, I'll send you an email, and if you have any question, you can schedule one-on-one. All right. Yes, thanks to Pankaj Maggie. And all right, so we actually I understood that's kind of required. Although most of the cases which I've taken in the class are from industry, but I understand that those were part of the problems, not the entire problem. Okay, all right, okay. No worries, Christine. I'm sure you'll be able to finish. If you're not, let me know a little ahead. And if you want to kind of if you are not able to finish the uh, on CloudX Lab and you want to extend, either you can renew by paying more, or if it's just that you want it for 10 days or 5 days, that our support team can extend that easily. Okay, for 10-15 days. All right. Okay, so that was pretty much. So we have actually gone through many things, and all right. So I'm sure that is difficult to cope up with so many things because teaching is easier as compared to learning. And okay, so all right. So in case you want to extend CloudX Lab, you can simply go to cloudxlab/mylab. You will see yourself already logged in, and you can extend from here. Or in case you just want to extend for a couple of days, you just drop us an email at support@cloudxlab.com. Okay, or you can just click on extend now. Okay, so that was pretty much about the Spark course. So if you have any questions, feel free to reach out to me. I would love to stay in touch with all of you. So because unlike the traditional way, we love to stay connected with our students because most of our students are from pretty good background. That's quite lucky for us, and that's why we would love to involve you in the future projects. So stay connected, and there are quite a few things which we are experimenting on. And once you submit the project, both projects, we will give you the certificate that you can put it on LinkedIn. And the submission date has been moved to October 30, October 30, which is hardly 7 days from now. Okay. And sorry, and the project submission is on November 6, 2 weeks from now. All right. So in case you are facing any difficulty, feel free to reach out to us at support@nobigdata. Okay. So we'll be able to help you out quickly if you are stuck somewhere. All right. And feel free to drop me a message. That will be good. Yes, assignment is Iron Man thing, but you can innovate on that. You can actually do a couple of innovation optimization on that. Yes. Okay. There are quite sophisticated techniques now available for sentiment analysis than the one which I've used. Okay. And the different tools you can try. All right. So it was a great learning experience for myself as part of this class. Thank you, Maggie. I'm happy that you liked it. And thank you, Christine, that you liked the session. Thank you, Deepak. Thank you, Dheer. Thank you, Sabanand. Okay. I'm actually amazed at the fact that there are 18 participants in the session because by the end of my previous sessions, people generally give up. All right. So I'm pretty happy with the team. And okay. So yes, I have done a little bit more. I've removed few parts of it and added more. And I'm sure I'll try my best to make it further better. All right. So stay connected, and I wish you best for your career. And it will all the things what we have learned in this session are going to be useful in one way or another in your career. So if you are not clear about something, feel free to drop me a message. Our most important part is that we want to keep it a long-term relationship rather than just the course. Okay. We don't have a transactional kind of relationship. Okay. So stay connected, and all right. Thank you, everyone. Bye bye. Thank you, Christine. Thank you, Maggie. Thank you, Dheer. Thank you, Bernie. Thank you, Sashi. Thank you, Hank. Thank you, Deepak. Thank you, Hari. Thank you, Harshvardhan. Thank you, Jayaprakash. Also, those who want to form the group, they can form the group using WhatsApp. You can message on WhatsApp group, and you can form the groups, and you can actually submit the project in the groups as well. Okay, and so on. All right. Thank you, Michelle. Thank you, Pankaj. Thank you, Dabral. Thank you, Shashi. Thank you, Venkat. Thank you, Madhu. Thank you, Leeladhar. Thank you, Jayaprakash. Have a good day and stay connected. All right. Bye bye.